We were looking at the chapter 9 sequence and series of the class 11th. So the most important thing is now the geometric progression. Geometric progression, see, these are certain sequences. In these sequences, just follow some criteria, or try to visualize certain sequence or relationship. So if we divide this 4 by 2, this one by this one, this one by this one, that is 8 by 4, 16 by 8, so 16 by 8, you get always 2, 2, 2. So there is a common value. 2 can be written as 2 into 1, 4 can be written as 2 into 2, then 8 is 4 into 2, like this. So every time you have this 2, 2, 2 common. Here also you see, this is, say if this is A1, this is A2, A2 by A1 gives you the value as minus 1 by 3, minus 1 by 3, minus 1 by 3. If this is divided by this is divided by this. Similarly for this also, you have certain pattern. The constant ratio is 0.01. This kind of series or this kind of sequence are known as geometric progression or geometric sequence. So sequence A1 to AN is called GP if each term is non-zero and you divide the number with the previous one, you get R as a constant. So now if first is A, next will be A into R, because we know AR by A is going to give you R. So AR by A, AR square by AR cube by R square. Every time we have A as the first term, R as the common ratio of the GP, right? Common ratio is of this geometric progression are 2, minus 1 by 3 and 0.01 as we have just seen. So now let us formalize it. The nth term we can find out. A is the first term, R is the common ratio, L is the last term, N is the number of terms, and Sn is the sum of n terms. So the general term of GP, as you see, this S, or say the first term is A, that you can write as AR to the power 1 minus 1, that is R to the power 0. Second is AR to the power 2 minus 1. So A2 is AR 2 minus 1. This is N, this is N. So you can write a nth term or say any nth term as AN equal to AR n minus 1. This is your AR to the power n minus 1 is your nth term. So this is your nth term. AN equal to AR to the power n minus 1. The first AR square like AR to the power n minus 1. These are the series. Okay, this is the series for you. This is finite if it stops, infinite if it goes on. When we talk about the sum of n terms of GP, as we have seen in the AP also. So if Sn equal to A plus AR square till AR to the power n minus 1. If R is equal to 1, what you are going to get? A, because every time you have 1, that is NA. What case can another be? You have R which is not equal to 1. Just multiply R, left hand side, right hand side. So R Sn equal to AR plus AR square, AR to the power 3, AR to the power n. And take this, you can subtract this 2 from 1. This one. This you subtract, you will lose all these. Only A and AR to the power n will remain. So Sn take common 1 minus R. So Sn 1 minus R, A take common 1 minus R to the power n. What you get? Sn is equal to A 1 minus R to the power n 1 minus R. This is the sum. Let us take an example. Find the 10th and nth term of this GP. So A is what? 5. R is 25 by 5, that is 5 is 25. A is 5, R is 5. So A10 will be AR to the power 10 minus 1. You get 5 into 5 to the power 9, that is 5 to the power 10. How about nth term? AR to the power n minus 1, 5 into 5 to the power n minus 1, 5 to the power n. This is the way to the answer. Next is which term of the GP? This up to n terms is this. So this, let it be the nth term. So A is given as 2, 8 by 2, A is 2, 4 by 8. R is 4. So this 131072 is equal to AR to the power n minus 1. You have to find the n. So you equate n with n minus 1 with 8. You get n equal to 9. So this is the 9th term of the GP. How about this one? In a GP, the third term is 24, 6th term is 192. You have to find the 10th term. So third term is AR square, because it is AR to the power 3 minus 1. AR square, A6 is AR to the power 5. Now you can divide these two. If you divide these two, you get R equal to 2, and you substitute it anywhere, you get A equal to 6. So the 10th term is 6, 2 to the power 9, that is 3072. Next is find the sum of first n terms and the sum of first 5 terms of the geometric series. 1, 2 by 3, 4 by 9. So A here is 1 and R is 2 by 3 by 1, that is 2 by 3. So just take sum Sn equal to A, 1 minus R to the power n, 1 minus R. You get this one. If you want some fifth term, take n as 5. So you get 211 by 81. Next is how many terms of the GP this are needed to give the sum this. So A is 3, R is 3 by 2 by 3, that is half. Sn is this one. So Sn is A, 1 minus R to the power n, 1 minus R. You have taken R as half, A as 3. Just solve it for n, you can get n equal to 10. Next is the sum of first 3 terms of GP is 13 by 12. So we take this term as A by R, first term, then A, then AR. These terms we take, we assume their product is minus 1. So first of all, just add them, it is equal to 13 by 12. These multiply them, you get minus 1. Here you get A cube equal to minus 1, that is A has to be minus 1. Place this A minus 1 is equal to minus 1 here, you get R equal to minus 3 by 4, R equal to minus 4 by 3. So the 3 terms, if you put this, you get this sequence, you put this, you get this sequence. The sum of sequence of this 2 n terms. So how to get the answer of this? Take 7 as common. You get 1 plus 11 plus 111 dot dot dot. Here, okay. You have taken 7 as common. Now multiply numerator and denominator by 9 and take 9 inside. So you get 9, 99, 99, 999, 7 by 9 outside. This one. How can you write 9? 9 as 10 minus 1, 99 as 10 square minus 1. You know that dealing with 10 is quite easy, and only one term, n term, this will become n term. So this 10 square, 10 cube, n terms, and 1, 1, 1, 1, n times. This is your GP. So this will be A, R to the power n minus 1, R minus 1, minus n. This is basically n term, so minus n. So this is your solution. So a person has 2 parents, 4 grandparents, 8 great grandparents. Find the number of his ancestors during 10 generation preceding zone. So A is 2, R is also 2 because 4 by 2 is 2, n is given as 10. N is given as 10 because 10 generations. So Sn is equal to A, R to the power n minus 1, R minus 1. That is S10 is going to be 2046 if you solve it. How about geometric mean? Geometric mean between two positive numbers, say A and B, it is going to be root AB. So geometric mean of 2 and 8 is 4. And C, 2, 4, 8, these are the consecutive terms of GP only. So this will lead to a generalization of the concept of geometric terms between two numbers. So if you have A and B, if you want various numbers between A and G, say you want some n number, how many numbers are there? These are n, this is n plus 1, this is n plus 2. So you have to, this B is actually n plus 2th term. So B is equal to A R to the power n plus 2 minus 1, that is B is equal to A R to the power n plus 1. So R you get B by A, 1 by n plus 1. So G1 is AR square, AR cube, AR to the power. This is how you get. So if you want to find out or get 3 numbers between 1 to 256, see these are 3 numbers, this is 4, this is 5. So in all there are 5. So 256 is what? A is 1, R to the power 5 minus 1, that is R to the power 4, R is plus minus 4. So if you take R equal to 4, you get these values AR square, AR cube. You take R equal to minus 4, you get minus 4, 16 and minus 64. How about the relationship between AM and GM? You have A as AM, that is A plus B by 2. G1, GM, geometric mean as under root AB. So let us find out the value. We'll take it by example. So AM and GM of A and B are 10 and 8. So A plus B by 2 is 10. A, B under root is 8. So A plus B is 20, and just take square of these two. AB is 64. But you know this formula. A minus B whole square is equal to A plus B whole square minus 4AB. So you take this A plus B here and AB here. So you get A minus B. A minus B is plus minus 12. So one time you take a this a minus b equal to 12. One time you take a minus b equal to minus 12. So for that you get one time a equal to 4, b equal to 16. Next time you get a equal to 16, b equal to 4. So these are the values of a and b. So this is one more installment of sequence and series. We are going to take one more. Thank you so much. Take care of yourself.